So unit number 1, which will talk about the introductory part of operating system, in which we'll try to define what is meaning of operating system, what operating system do for us, okay, how to interact with operating system. We need to see the performance of operating system also. Then we need to talk about the evolution, because whatever the modern operating system we are interacting with nowadays, and how the journey actually started with something called as a serial processing, then come into existence like batch processing. Then there is a concept was the time sharing systems, then multi-programming, then multi-processing, multitasking. So many keywords are used, and these are important to understand because uh, if you see, this is one of the core course in computer science program. Even if you want to go for higher studies, most of the examinations we need to gone through go through. So for example, gate exam and other exam also. So this is one of the core subjects. So uh, this operating system course gives you internals of operating system, and we need to perform practicals on this also, because we have lab course for it, and whatever the concept we'll study here, we will try to write either a simulation kind of a thing, or we'll go with its details. Uh, when you go through the lab course, no specific language is mentioned here. So we have a flexibility here. Either we'll go with C language, C++ language, sometimes maybe with Python. If you wish to go through Go language, Java is there. Okay. So we'll try to make use of any language. So that flexibility is with us. The thing is, we need to understand the concept and then implement those concepts. Okay. So the time sharing systems, the real time operating systems, what are different operations that we need to go through, or the operating system provides us. Somebody is saying we should go with Python. No, we will not restrict ourselves to any language. Important thing is, if you are comfortable with Python, no problem. You go with Python. Maybe one assignment with Python, one assignment with Java, one assignment with C++, wherever whichever language is suitable. So we don't want to bind operating system with any specific programming language. That flexibility will give. So if you are uh, want to use Python, no problem, because this is not any programming uh, language course. So whichever facility is available in the programming language, that language will pick up for that topic, no problem. Okay. Or wherever possible, the same concept will try to implement with multiple languages also. So that way also do. Anyways, that I'll post it on Moodle. So first unit will talk about the introductory part. Important part in that is the different types of kernels, like monolithic kernel, microkernel, or modular kernel, and like we have embedded operating systems also. Nowadays, the concept of virtual machines, where all the hardware is virtual. Okay, so even though I am saying I have a 20 GB of hard disk, actually it is part of maybe network storage also. So virtual machine operating systems, that so anyways, it is just kind of a introduction for different aspects of operating system, right? Am I audible to everyone? Okay, no issues, fine. uh, I think one response is sufficient for me. Okay, so unit number 2 is the process management. If you think of any operating system, especially modern operating system, then the core part of your operating system is the number one is the process management, second thing is the memory management, and third thing is file and IO management. So three the important components I can say. So second unit we immediately start with the process management and fine. So with process management we need to understand what is meaning of process. Anyways, we'll define what is process, how to create a process, what are different operations we can perform on process, and the important task is inter-process communication and inter-process synchronization. That part is somewhat important because you think of traditional operating systems where we have a single processor and that operating system was suitable for that purpose, but like we have dual core, quad core, even multi-core processors are available, and now in order to utilize different cores we need to create multiple threads or multiple tasks. Tasks can be executed by processes also, they can be executed by threads also. So the multi-threaded programming and multiple processes. Now important parts, multi-programming is one of the keyword, multitasking is one more keyword, multi-threading is one more keyword, multi-processing is one more keyword. We need to clear cut understand difference between all the four. The reason is depending on these concepts we need to move to the advanced topics like inter-process communication and inter-process synchronization. Let me give one example. Think something like you have 100 numbers in an array and you want to sum it all. Now think you want to do it manually. If you ask one person to sum all 100 numbers with you, definitely it will take some time. Now suppose you have 4 person with you. Now what you'll do is maybe you will distribute 100 numbers. So 25 number for person 1, 25 number for person 2, 25 numbers for person 3, and last 25 numbers with fourth person. Now definitely this will fast because every person has limited task. Previously single person was doing summation of 100 numbers. Now 4 person doing the same task. So definitely you will need less time. But again you will get subtotals. 4 subtotals you need to sum up and then you will have a final result which is sum of 100 numbers, right? Now you think the same thing you want to do with your program. You want to do the same thing with your operating system. So in says any programming language, I can have just a single for loop which will run from for I is equal to 0 to 100 or 1 to 100 for that matter, and sum is equal to sum plus whatever the number that is stored in the list. It could be array, it could be anywhere, right? So that is what happens with the single thread of execution, single process executing there. The only drawback of this is, for example, it is perfectly okay if you have a single processor. But what if you do not have any other task and you have a quad core processor? So 4 processors are there in your computer and you are just utilizing single. In this case, is it possible to divide the task? So answer to this question is yes, we can divide it in 4 subtasks where every task will be executed by a separate processor or separate core for that matter. And then definitely you will get the fast result. Your problem will be solved quickly. But then the requirement is when there are 5 different processes, think of one is the main process and 4 are say worker processes. They are doing summation of 25 numbers. Then the main process has to communicate Summation of which numbers? Those numbers you need to convey. That is what one process needs to have communication with other process. IPC. This is called as IPC, inter-process communication. Exactly same manner, when worker process finishes its task, it has to convey the result of that computation to the main process. That again comes inter-process communication. And now what is the synchronization? Synchronization is, for example, once main process shares the numbers with workers, main process cannot add subtotals until the worker process finish their task. So one process has to wait for other processes to finish. This is called as inter-process synchronization. And whenever multiple processes are working on the same problem, they are solving the same problem, then if something is shared, that must be used very securely. And in operating system itself, it is called as a critical section, where only one process should be there at a time. So how to accomplish that? Different algorithms are there for that, like Peterson's algorithm is there, then semaphores are there, monitors are there, and then we'll see the classical problems of synchronization. The classical problems for synchronization are really very good. There are something like dining philosopher problem, producer consumer problem, reader writer problem. They are very well known problems of interprocess synchronization and interprocess communication part also. In addition to these two concepts, these are really very interesting concepts. We need to see about process scheduling. Like for example, even though I have written or the application with say 5 threads or 5 processes, and if there is a single processor or multiple processor, doesn't matter which process will be selected for the execution, that part we need to talk about, that is the process scheduling. Anyways, there are different scheduling criteria, scheduling algorithms are there. If multiple processes are there, then how scheduling happens. If single processor is there, how scheduling happens. All that stuff we'll see in unit number 2 and unit number 3. So this is unit number 2 and unit number 3, almost it'll have more weightage, the concepts of process. So the process concept, process management, process scheduling, inter-process communication, and inter-process synchronization. So we need to spare more time for unit number 2 and unit number 3. Okay. Moving to next, unit number 4 is deadlock. Deadlock is something like multiple processes are running in the operating system and not a single process is making progress towards its completion, because think of something like 3 processes are there, P1, P2 and P3. P1 is waiting for P2, P2 is waiting for P3, and P3 is waiting for P1. This is typically called as circular wait. So P1 waiting for P2, P2 waiting for P3, P3 is waiting again for P1. So all the processes are just waiting and not making any progress. This situation is called as deadlock. So unit number 4 will discuss about deadlocks. What are the characteristics of deadlock? Why deadlock occurs? How to avoid the deadlock? What are different deadlock prevention methods? Anyways, if still deadlock happens, how to recover from deadlock? So 3-4 algorithms are there in the deadlock. So we'll see different solutions for deadlock. One of the classical problem, if let me tell you, dining philosopher problem that is available there in the interprocess synchronization. One of the classical problem of synchronization. You think of something like you have a round table, and assume that there are five philosophers sitting on round table, and in front of them five plates are there. Okay, and on left side of a philosopher there is a fork, there is a one fork, and at a right hand side there is one fork, and this is same for all. Meaning of that is, if five philosophers are there, philosopher number one, and suppose philosopher number two is at right hand side of philosopher one. Now what will happen is, the fork on right hand of philosopher 1 and fork on left hand of philosopher 2 is the same. That means they are sharing it, right? So if five forks are there, what will happen? In order to start eating, the condition is philosopher should have two forks, one in left hand and one in right hand. And philosopher can pick up only one at a time. Now suppose every philosopher picked up just fork on his left hand. What will happen is, every philosopher will have one fork in one hand and waiting for other. Now this situation is deadlock. That means nobody can now continue. Anyways, we are going to see in detail what is this dining philosopher problem is, what are the possible solutions. We are going to write program for that also. Just to understand what is deadlock, I just quoted the example. So deadlock, we need to see the characteristics. What are the conditions that are sufficient and required so that system will move in the deadlock? How to prevent that? How to avoid the deadlock? Anyways, once it happens, how to recover from deadlock? All that stuff we'll see in the deadlock. So this deadlock unit is more closely related with synchronization. So for deadlock also we need the concept of process and the concept of synchronization. Unit number 5 is memory management. Here we'll see all types of memories, what are different strategies used by your operating system to assign or to allocate memory to different programs. And here one important thing, whenever I say program, one thing should be very clear: program is executable file. Because now the course is not C++ programming, where programming means source code. No. Now we are dealing with the course operating system. So from the view of operating system, program is executable file. Now for a programmer, say for example I am a C++ programmer, whatever .cpp file is there, that is a program for me because I am a programmer. But operating system has nothing to do with .cpp file. We need to make use of proper compiler to compile .cpp file. It will create the executable file, and now that executable file is of use for operating system. Operating system will load that and it will execute. So we always say executing programs. So with respect to operating system, program is an executable file. Okay, so we need to assign or allocate memory to those programs. So we will see what are different strategies for that, which starts from all complete whole process should be there in the memory. So right from that, so the concept of swapping, then contiguous memory allocation, then segmentation part, then paging, then demand paging. And before demand paging, there is a concept of virtual memory. Because the memory allocated by compiler, the static memory, whatever the memory required by my program is allocated by the compiler, and it is not physical memory, it is a virtual memory. Even in your programs, if you have used pointers, suppose in C language I declared a variable int a, so a definitely has address, and if I want to display the address, we say printf %u ampersand a gives me address of a. Now whatever the address displayed, it is not from your main memory, it is not from your primary memory, it is from virtual memory. So the concept of virtual memory we'll see, and once we finish that, we'll move to demand paging, where there is no need to load complete program into the memory in order to execute it. So for example, I have 1 MB executable file, no need to load all 1 MB in my memory. If part of that is loaded, yes, no problem, that program will execute because of virtual memory concept. So that is unit number 5. Unit number 6 is disk management and IO management, where the secondary memory, again this is one more important concept, because once I say memory is like primary memory, secondary memory, cache memory, all different types of memories are there. But when I say RAM, yes, RAM is your primary memory, and then hard disk or simply disk, it is secondary memory. The unit of storage on disk is in terms of block, not in terms of byte, because it has huge storage as compared to your primary memory, that is with RAM. And for that, in order to manage data on disk, we need a separate data structure for that, and that is nothing but your file system. So as I mentioned, the processes part is one core component, memory part is second core component, and third core component is your disk management, IO management. So different disk scheduling algorithms are there. Very simple example. For example, if you have 8 GB of pen drive, if you see the capacity, it is not 8 GB. It will show you something less than that. Why it is so? Because we need to employ the data structure on it, which will manage the structure of disk, which file is stored where. All those indices will be available in the file system, and we employ the file system when we format the partition or disk or pen drive, whatever. Then disk scheduling algorithms we need to go through. So that is about the disk management and then IO management. Now for IO management, IO basically stands for input and output, whatever different input devices and output devices we want to connect to your computer hardware, computer system. Operating system has to deal with those IO devices. Okay, and for that there is application IO interface. Typically it is broadly categorized into program controlled IO and interrupt driven IO. The kernel IO subsystem, that part we'll discuss in this. What are different hardware operations we want to perform on the IO. Okay, so that will be unit number 6. So total 6 units, weekly 3 lectures we have for this course. Assessment scheme is the same common thing, ISC1, ISC2, MSc and ESC. Textbook, the Galvin's operating system principles, even though 8th edition is mentioned, no problem, even though you have 6th edition or 7th edition, doesn't matter. because those many things are not required. For unit number 1, there is a book by Milan Milankovic, Operating System Concepts and Design. Anyways, they are very generic, so no need to worry about that for unit number 1. I have a soft copy of this book also, so even though you are not able to come to get the book from library, I'll upload this silver cards or Galvin book on the Moodle, and you can access it there, no problem. So, and that is sufficient, I guess. Whatever the programming part of this is concerned, I already mentioned, will be open for multiple programming languages. Important thing is we should write program as close as the concept is, and whichever is the best suitable programming language for that, we'll use it. That's it. Okay. Just I want one feedback from you because you are in third year. Uh, Officially, I guess you know C and C++, and I think Java you are learning this time. Okay, so maybe we can use Java also if possible. If you have learned Python on your own, no problem. We'll go with that also. We'll allow submission for Python also. Even other languages uh, are also welcome. Absolutely no problem. Just the thing is, you need to understand the concept of operating system, and then we'll say, for example, the problems of synchronization, or maybe how different schedulers work. Okay, we'll go with any programming language, no problem. So anyways, there is still some time for that because uh, we need to start with unit number 1 first of all. Okay, and maybe from unit number 2, when we start with the concept of process, practicals will start. So till then, we'll go with the theory session. Just the thing is, will not restrict ourselves to any specific programming language. But then again, the thing is, we have POE for this, for the lab. Because for a lab course, if you see the ESE, this is the lab course with the course code 533 UCSE 0533, and if you see the assessment part of this, yes, ESE is there. ISE 50, no, ESE is not there. Yes, ESE is there. Again we'll check with the structure. But if you see the list of experiments, these are very generically mentioned. Installation of different operating systems, what are the steps involved there, study of MBR, customizing grub loader. This is typically required for dual booting operating system. MBR stands for master boot record. We'll see this also. Then configuring different services for operating system, that part is required. Study features of different file system, analyze different CPU scheduling algorithms, and for this analysis, Gantt charts are used. Maybe we'll utilize Python language to generate Gantt charts. So given the processes and their arrival time, their finished bus time, so everything, those concepts will implement. Then the process management using different system calls. Now because system calls involved here, the best suitable language here is C++. Anyways, still if multi-threading you want to do, you can do multi-threading in Java also, in Python also, in Go language also. You can utilize anything, no problem. But when it is concept of process and system calls, we need to go with C++. Okay, so drawing some resource allocation graphs. There is a bankers algorithm used in the Deadlock chapter, I guess 4th unit. So this bankers algorithm is there. Then from memory management, different page replacement policies are there. Here also we can utilize any programming language, doesn't matter. Whichever your favorite programming language is there, you can utilize it here. Similarly, disk scheduling algorithms, this will analyze performance by simulating. Now here we'll make use of simulations because we don't want to actually write on the disk. Okay, so we will have simulations here. Fine. Any questions from your side? Any questions from your side? I can see 54 participants. Anything that comes in your mind, you can put it on chat also, no problem. And this the course is kind of generic. This is not related with any specific operating system. Like earlier we have operating system 2 also, wherein internals of Unix are there. So that is very related to Unix operating system. Okay, so this is generic. So whichever operating system you prefer, will try to map the concept to that operating system. But as Linux is open source, we can have internals of that. So maximum will try to utilize open source operating system. It could be any flavor. There is concept of POSIX used to implement threads also. POSIX is basically a system where we have portable operating system information exchange, where you would be able to write portable application developed on one operating system and that can execute on another operating system. Okay, so this is all about the syllabus contents. Can you see this? I just open another PDF file. What is operating system? Okay, no problem. So if you want to define what is the operating system, now it is really very vast thing to define. Reason behind that is the journey of operating system started with single serial processing, and today we have lots of operating system, not just in number but in its types also. Like time sharing we have, then multi-programming, multi-processing, parallel operating systems on virtual machine. So many things are there nowadays. Okay, anyways, we need to go through that evolution of operating system also. In all, the very generic definition of operating system is it's a program. Now this is interesting part. Operating system itself is a program which will directly talk with your hardware. Okay, and why it talks with hardware? It is for you, for the users of operating system. For example, if I say show me the contents of some XYZ file, it will talk with your hard disk, it will read from it, and that definitely needs drivers for that hard disk. It will fetch the content. Now it will talk with another hardware, which is your terminal, and it will display the contents there. You are getting the point. So that means it is working as an interface between, or intermediary. It's the interface between the user. And again, interesting part is user is not necessarily people. Another program could be user of that. For example, I can write a program which will show the contents of file. Getting it now? That means that program is user of a hard disk. Okay. And if you can see that, yes, people, they are also users for the operating system. So it is altogether different views. Who is user? So user of operating system could be anybody. So operating system is basically interface between your hardware and the end user of that. And the goals of operating systems are to execute programs. As I already mentioned, programs are your executable files. So executing the programs and solve user problems. Anyways, we are writing programs for that. But while doing so, your computer system should be convenient for the users. So making your computer system convenient is also another goal for your operating system. When we compare operating system, like if I ask the question which operating system you use, and if somebody says Linux, now my next question is which Linux. Few may say Ubuntu, few may say Debian, few may say Red Hat, Fedora, SUSE, Kali, whatever different flavors are there. Why? Because you feel convenient with that. That is one of the goal of operating system, to provide convenience to the users. And of course, whatever the resources you have, hardware resources, it could be RAM, it could be processor, it could be disk, it could be printer, it could be anything, any resource attached to your computer hardware. Those resources should be used in very efficient manner. I just got notification, just 3 minutes are remaining. So before moving to next slide, we'll stop here only. We have still 1 or 2 minutes. So if you have any question, go ahead. Otherwise, we'll stop.